Welcome to qnawire.
So this graph represents the behavior of barium carbonate under different circumstances. So in each case, the vertical axis is solubility and the x-axis is concentration of some other reagents. So which of the graph represents what happened to barium carbonate as HNO3 is added? So if you have barium carbonate dissociates to produce barium 2 plus occurs, and CO3 2 minus occurs. So in the presence of an acid, the acid will cause the formation of bicarbonate from the carbonate. You're gonna have HCO3 minus. So if that is the case, if the acid causes the reaction with CO3 2 minus to form HCO3 minus, then the CO3 2 minus will be removed as it is formed, and that will shift the equilibrium towards the dissociation of barium carbonate, and that will lead to an increase in solubility of the barium carbonate. So if the concentration of the acid is increasing, then solubility of barium carbonate should be increasing. So the A, if we call this high, 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 and high, 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 here the answer here would be graph or curve 3. Or graph 3. B says which graph represents what happens to barium carbonate as Na2CO3 is added. So if we keep adding, so just like we have here, if we had Na2CO3, that means we'll have excess of CO3 2 minus ion in solution, because the Na2CO3 will go into solution to produce Na plus CO3 2 minus, and the excess of this CO3 2 minus will lead to the increase in concentration of the CO3 2 minus in solution, and that will lead to the increase in the concentration of CO3 2 minus, which will cause the concentration of the whole species in solution to exceed the solubility product of the barium carbonate, and that will lead to the precipitation out of the solution of that will lead to barium carbonate precipitating out of the solution, and that will cause a decrease in the solubility of barium carbonate. So the graph that depicts that is the graph 1, where the increase in concentration of the other reagent leads to a decrease in the solubility of barium carbonate. So this is graph 1. C said, which represents what happens to barium carbonate as NaNO3 is added. So if you have NaNO3 will go into solution to produce Na plus and NO3 minus. So neither Na plus nor NO3 can interfere with the CO3 2 minus. Rather, the Na plus can probably react with the CO3 2 minus to form Na2CO3, but that depends on a lot of factors. So the graph that depicts that could likely be graph 2. So like nothing really changed.